Hi, the Astro 30 here, and I've got absolutely nothing to present except a dirty desk. Just kidding. Greetings, the Astro 30 here yet again, and welcome back to AEL, and I have some PCBs. Now, if you're new to this channel, please consider going down below there and subscribing if you haven't done so already. Cheers, that'll be very helpful to me. Now, this is the first time I've seen PCBs from PCBWay come in the box wrapped, sealed in plastic. That's the first time for me. So, I'll just clear off the plastic. And I'm going to turn it over because of personal information's on the other side, so we'll work on this upside down. It does still look like the box is taped shut, other than just the plastic, so I'll get rid of the plastic. I'll cut the tape, if I so can. Okay. And here we go, some PCBs. Excellent, let's just get rid of the box. Now previously on the channel I did a guitar practice amplifier design, which was a pedal that I found a schematic online for. And so I decided to make a PCB for it. Now I haven't used the LM386 as the power amplifier, so I'll get the boards out of, well, a board out of the plastic bubble wrap. So here's the PCB here with PCBWay's logo on there. I put that there, they didn't. Now, over here is the power amplifier section, and some of you on the channel may recognise this little power amplifier as a design I did back in 2023, I think it was, for a mini power amplifier. It was based on a BD 139 and 140 output stage, and it produced close to 700 milliwatts into 8 ohms. It's more like 500. And I found that this particular amplifier works better with the high gain circuitry before it and doesn't go into squeals and oscillation. I did also try a different experiment here. I have not used plated through holes for some of the components, at least I don't think they're plated through holes. These ones over here are plated through, but these do look like they actually have copper on them, so they may still be plated through holes. Yeah, I thought that would be okay like that, and it would just be like you'd only have the solder pad on this side. Nice little bass guitar image there. But no, it looks like they have still done plated through holing where it's not supposed to be plated through hole. So that's kind of annoying. Kind of annoying. I'd have to look under a magnifying glass as to how that is. Now I'm waiting on some 1 ohm half watt carbon film resistors. They haven't arrived yet, so I can't really assemble it without them because I don't want to use, did I say carbon film? I meant metal film. I can't really assemble them with carbon film. I can, but it produces a little bit more noise. But what I want to show here is these cute little knobs that I found for the potentiometers on Ultronic's website, which I thought would look absolutely gorgeous on the pots that I've also got sitting off to my left here. So yeah, I'm going with those. So I'll pull one out and we'll have a good look at the pot. They're only 10 millimeters in diameter. But then again, the pot spacing on the board is 20. There's a good look at the knob. It's got a nice positive indicator there, and it's a 18 tooth splined shaft, and I reckon that'll look sexy as hell on a front panel on this board here. So there were comments on the first design, which I'll link in the description, of getting the LM386 amplifier to work properly with this by using DC decoupling. Well, the high gain stages are DC decoupled from the main power supply. I probably could have DC decoupled the output amplifier as well. That's just adding a resistor and a capacitor to ground, and then taking the VCC line off of the capacitor resistor connection to power the amplifier chip. I did think about that, but I just couldn't be bothered messing around with the circuit too much. So I've also got some heat sinks from J-Car. Bring another little baggie. I just want to make sure they fit. Now I was going to try and get the ones from Ultronics that were 15 by 10 millimeters by 16 or so high, but they didn't have enough available for delivery, so I just went with these ones. They'll overhang the board a bit, but they should, if I made the holes big enough, which I thought I did, fit in the board. Oh, it's tight. Yeah, I probably didn't make it quite big enough. Now I can't get the bastard out. I mean, with some wiggling they'll go in there, so I might actually try and get them in there first when assembling this, so I can, like, you know, put some pressure on it, do it on the desk. And yeah, the heat sinks are going to get in the way of assembly, but that's alright. Just make sure the socket fits. Yes, it does. Excellent. So, as I say, I can't really assemble this without the 1 ohm resistors. But yeah, I'm still not 100% happy with these holes still being plated. They shouldn't be, because there's no copper layer up here. Let's have a look at the finalized schematic first, and then we'll get into assembling this thing. So here's the schematic. It's pretty much the same as the original one. There's just a couple of differences, or a few differences. We've got these two diodes here, so we can actually have a battery for power, or a 9-volt DC to 12-volt DC jack. And this just allows you to have both of these connected at the same time, and the plug pack is not going to try to charge the battery because it can't go through this diode. So most of the current flow, if you have both connected, will be through this path rather than this path, but there will be some current flow from the battery if you've got it installed. But I just left that as an option just in case somebody wanted to make this a portable amplifier. It goes through this power switch, and we've got a 1000 microfarad smoothing capacitor, and we've also got this DC decoupling here with this 220 ohm and 100 microfarad capacitor. There's our rail splitter resistors, the biasing resistor for pin 3 of the NE5532. I'll look at the original video, which is linked in the description, for a description better of this schematic. I'm not going to go over it again. The only other difference here is I've changed the style of the tone control. Now we're using this instead. Originally we had I think it was 22 nanofarad or 47 nanofarad, whichever one it was, in the ground path of the pot, and that was causing it to vary the volume of the output too. So I found by putting this with a capacitor across it works a lot more effectively. So this is turning into a low pass filter. The more this comes to ground, then the more that this is going to act as a low pass filter. Same as we've got a low pass filter here, this adds more low pass filtering. That goes through the volume pot into the Class A/B power amp, which is also linked in the description. So you can read up on or watch up on that. In the build, I'm going to leave this 22K feedback resistor out, because during testing with this module that I've got a working version of, when the drive is set to 0 or fully counterclockwise, there's not much gain at this end coming through the circuit, and the volume control has to spend most of its time at full volume to get any decent sound out of it. So I may want to adjust this resistor, increase it to give a little bit more gain to this amplifier so that the volume control can spend more time at, say, half its volume to get decent sound out of it. So I'll just install a temporary 100k trim pot or pot across this point where the resistor goes, and so we can vary the resistance and increase it and change the gain and see how we go. I will have to be careful with this that it doesn't start to turn it into like motorboating or oscillating, because it's just too much gain. So that's why I have a variable resistor, so I can, get it into its sweet spot. And during the test, I'll actually be testing it on 12 volt DC, not 9 volt. So we get the best possible output power of this thing. We don't want to exceed any more than 12 volts because these electrolytic capacitors are only rated at 16 volts. So that's it for the revised schematic. Let's get back to some building action. Okay, so that was the schematics, and not much has really changed from the original design except the output stage. So I'm going to start assembly, as I said, by trying to force these heat sinks. I know you shouldn't really force stuff, but it will go in there if I give it a little bit of pressure and wiggle it back and forth. You'll never get it back out again, of course, but I don't think that's really going to be a great issue. It's almost flush with the board. I mean, I could ream it out with a drill bit, which I probably should have done, but it's a bit late now. Although, because it doesn't really need to be plated through hole for there. We have enough structural rigidity on that side. So, let me just get a drill bit. That's a bit better. I'm just going to solder these in using some leftover solder from a kit build. And it will take a little bit more heat because the heat sink is going to do its job and remove the heat. It's not going to make it any more awkward to assemble in any way. It's just if you're doing things flat on the desk, then yeah, it may cause issue with assembly because things are in the way, but at this point it doesn't matter. So there we go, they're soldered in and they're flush with the board, so I'm happy with that. So now all I've got to do is just populate the rest of it, and yeah, then we can go from there. Okay, and that's most of the assembly there done. I haven't installed any of the transistors in the power amp stage for the simple reason that we still don't have the 1 ohm resistors in the emitters, and I don't want this driving an output stage that's not connected to anything and left in open loop gain, because it may destroy other transistors in the circuit, and I want to avoid that. So the next thing I'd have to do is, I'm going to test it anyway, just to see if the preamp actually is functioning. And of course, in order to do that, I've got to install the IC. So I'm going to install that now. And I've also got to prep the pots. And what I mean by prepping the pots is, if I can get this to go in the socket without bending the pins the wrong way. I believe that's in, yes it is down here there's a spot marked pot ground. That's to go for a ground strap across the top of each of the pots that is soldered to it, just to earth the case of the pot, or ground the case of the pot, so that if there's no knobs on it, you're not picking up noise by touching the shafts of the potentiometers like it's causing a buzz. You'll also notice there's a test point here. That comes before the volume control and after the tone control. And that allows us to do one of two things. Either test the preamplifier operation before the volume control, or inject a signal into here to test the power amplifier. So I need to grab my pots, which are in this bag of parts here. There's two 10Ks and there is one 100K linear. The two 10Ks are here in the same bag. They are logarithmic. So in order to prep this, I'd have to, one, get them out of the bag. I would have to install the nuts and washers for a start, but I might do that in a second. But I want to break this tab off that's on each of these potentiometers, because it's not going to be used. It's going to be mounted flush to a panel, so these aren't really needed, so they can be negated like that. And this one too. Missed. Oh, that one's tough. Alright, got it. Okay, and I'll need to file off a little bit of the top surface of each pot just to make it easier for the solder to adhere to, and solder it into the board. So I'll do all this off camera, and I might even put the knobs on too just to see how it looks. So let me do some work off camera and we will come back when I've got some further results. Okay, and there's the potentiometers installed with the grounding strap, and I've put the knobs on, but I haven't put them on all the way because they are a tight fit, and I want to be able to pull them off without putting too much stress on the pot and the joints on the board here. And they do actually look quite nice on there, I must admit. They look pretty sexy. Yeah, I'm quite happy with those. These, funny little mark there. Anyway, these were about, I think, from memory, they were like $1.75 each. I have to check the invoice here as to what they are. They're $3 each, actually, I think. No, $1.25 each. So there's 3 of them. So that ended up being $3.75. Yeah, knob plastic, 18 tooth, black, white, 11mm, it's 11 not 10, each, including GST. Net price is $1.25. So $3.75 for all 3. That's not too bad, they're pretty cheap knobs, but they look very, very sexy. So, yeah, so now I have to test this thing, and in order to do that, I'm going to have to make up some crimp cables in order to do it, so we can plug into the headers. Now, the LED will be having a header there going off to the front panel, and it won't be mounted to the board. I just haven't installed it yet because there's no need to, and I don't really want an LED with wires on it floating around on this circuit board loose like this that's not actually finished, because yeah, it's just pointless. So let me spend the next, I don't know, 20 minutes or so making up all 3 cables. I need the DC, the power switch, which I'll just join the 2 ends of the wires together to make the switch contact, and the speaker output wire. So well, actually I don't need the speaker wire output at the moment, do I? Because there's no power amp to test. But considering I'm going to be doing the crimping anyway, I might as well do it. So I'm not going to crimp the battery one at the moment because I don't need it, I don't have a battery. And as I said during the schematic at the start there, that I'm going to be testing this at 12 volts. So let me get to doing some crimping and then we'll come back. Okay, and about 20 minutes later I've got the wires all crimped. So the speaker cable switch is soldered together so it's joined, and the power input. I've also stuck in a green LED in the footprints there so we can see some visual indication. I only had one casualty. This went sideways in the crimp and like that, and crimped real badly, so I've lost one connector. But that's alright, I do have some spare ones. I got 60 of them at one point, I've got probably about 50 of them left now. So that's fine, I can get a replacement for that because I've only got 3 now. I need 4 for the other 2 connectors, but that's okay. Now I need to set up to test the preamp section anyway, so I need a signal generator, power supply, and the oscilloscope. And with these signal diodes down in here, you can use red LEDs if you wish, and just fashion them to fit into the footprints there where the diodes went. If you want a much more subtle clip, it's up to you. I like the sound of diodes personally, but it may look a bit wanky, but it can be done. So alright, let me set up the test equipment to do this test. Penis. Alright, I've got everything set up. Got the signal generator at 1 kHz currently going into the input socket with a plug plugged in so I can connect my leads to it. Scope's connected to the test point. Power is currently off and the supply set to 12.2 volts. Turn on the supply. Well, the LED lit up. However, currently I don't see a signal. Maybe because the generator is not turned up enough. Or it is completely dead. One of the two. Well, okay. I've got no signal output. We are running. Yes. Oh, there it is. I must be too low on my voltage. There we go. We now have a nice sine wave coming out. Although I've got my generator up quite far, or is it just not making good contact? Something's... I think it's my input connection's not making good contact there. Let me reconfigure this so we've got a decent connection at the input there. Much better. Alright, so I'm going to drop my signal gen down, well, to about there I think, which would be about roughly where a guitar input is. And it is soft clipping nicely, and the gain is reducing when I back the control off. That's good. So I need to figure out, so we're clipping there, but it is looking pretty soft. That's with the tone control full up, and by varying the tone control we can see that the shape is changing. So yes, it is functioning and seems to be functioning and clipping when it needs to okay. So far I'm happy with that result. Well, thanks for watching. No, only joking. I am going to finish off the build in this video, which will be in the next couple of seconds for you, but about half a week for me because I've got to wait for these bloody resistors. But I'll get the resistors next week sometime, install them, install the other transistors, and then we'll come back, pick the video up and test the output amplifier, and then put it into a speaker and see how it sounds. Catch you soon. Well, me being me, I can't wait for the resistors to arrive, so I've got a couple of carbon film resistors in there, 1 ohm, and a 22k feedback resistor just jammed in the holes. They are plated through holes, but I've got a problem. It doesn't work. We're missing the negative going cycle, probably a bit of the positive going cycle as well. So yeah, that's a problem, and I don't know why. And this heatsink here is starting to get quite warm, and this one is very cold, so it's most likely the PMP transistor is not really doing anything. Another fun fact, if I kill the power, it's as if we almost get a complete waveform there, which is strange. So why doesn't this circuit work? And it's not a routing issue because it's routed the same way as the original board it was designed and based on. Bugger if I know. Alright, so I've got the good working module hooked up. I'm going to measure at the base of the NPN transistor here sometime today. So 4.3 volts. Okay. At the junction between the two diodes, it's 3.5 volts, and at the base of the other transistor, the PNP, come on, make contact, there we go, almost, 2.8 volts. Right, so if we do the math, there's 4.2 there, you take 1.2, should be about 3 volts. And it is roughly 3 volts. So, what's the other module doing? Okay, so at the base of the NPN transistor, 1.5 volts, which is not right. There's too much of a voltage drop there. Even though we're going through a diode here on the power supply, it's only dropping by 0.6 of a volt. The supply is at 12.7. We should still see close to 4 volts there. So at the junction between the two diodes, 0.8 of a volt. Again, well, that would be right with what that voltage is here at the base. 0.6 less, so yeah, you'd be at 0.9. And at the base of the other transistor, 0.069 NAFL. Yes, those voltages are not correct, and this transistor here is not even being biased on. Why? Don't know. Either we've got a defective, we may have a defective NPN transistor, which is why we're getting such a large voltage drop there, or this transistor is faulty, but they all test out fine, so yeah, I don't know. I'm going to try actually unloading the emitters. You shouldn't really do this. See if it makes a difference to the voltage reading. No. So it's still only 0.07 volt there roughly. So what I'm going to do now is, before I start messing about changing transistors, which I shouldn't have to do, I'm going to wait until the actual 1 ohm resistors turn up so I can solder them in permanently for a start, so they're not just floating around. And I'll shoot another video on this, so I'm going to end this one here, but I'll do a few other experiments with the board. I mean, it was free because I'd had enough in my PCBWay account balance through vouchers and stuff to actually end up with free shipping and a free board. So I haven't lost any money on this except for the parts that are on the board. They can all come back off though if I want to rebuild it again on another PCB, like a revision B. But there's no routing issue, so yeah, I don't know. After that 330 ohm resistor, we should have about 4 odd volts there, but we don't. It's being held down to 2. So something is not right, and this transistor does get hot even when it's idle, not going into a load. So that's being probably driven into full conduction, and the PMP is not doing anything. So tell me your thoughts down below, what you think could be wrong with this. And as I say, I'll make another video going through and checking things and trying a few other things, and then basically just give up after that. No. I did actually test it with the LM386 circuit originally that it was designed with on a breadboard, and it doesn't oscillate or carry on like it did in the beginning. It must have been because the layout of the front end was so piss poor that it caused it to oscillate, but it's not oscillating now, so I can always redesign this board to use the LM386 if I so wish. So yeah, it's a shame I didn't get it working fully in this video, but it is what it is. Anyway, if you enjoyed this video, please remember to go down below, comment, like and subscribe if you haven't done so already. And this is the Astro 30 saying, as always, have a great day, thank you for watching, see you in the next video.